Correlation coefficients. In this video, you'll learn how to describe the goodness of a fit of a linear model using the correlation coefficient. You'll also learn how to match the correlation coefficient with a scatter plot and linear model. So let's look at correlation coefficients. The correlation coefficient, which is represented by the letter R, is a number that tells us how strong and directional a linear relationship is. The value of R can be between -1 and +1. If R is equal to +1, then it represents a perfect positive correlation. And if R is -1, then it's a perfect negative correlation. And if R is 0, then there is no correlation at all. So let's look at an example. We're going to determine if each scatter plot has a positive or negative correlation coefficient, and then we'll decide if it's closer to 0 or positive and -1. Here's our first scatter plot. We can see that they're increasing as we go left to right. So this represents a positive correlation. The lines also form a really nice linear pattern. So this tells us that it's going to be closer to 1. Here's another scatter plot. This one kind of has dots all over the place. So this one has no correlation. So this will be closer to 0 since 0 represents no correlation. Here's one more. We can see the points heading down as we go left to right. So this will be a negative correlation. Now we need to determine if it's closer to 0 or positive or -1. We can kind of see a linear model forming, so it will be closer to -1. So it'll be closer to -1, but not very close because the correlation isn't super strong. Now let's decide which of the following correlation coefficients indicate the strongest correlation. Here are the options we have: 0.01, -0.34, -0.82, and -0.95. So a strong correlation means that it'll be close to +1 or close to -1. Values that are close to 0 represent no correlation. So we can see that -0.95 is the closest number to -1 or +1. So this will be the strongest correlation coefficient. Now we'll match each scatter plot to its correlation coefficient. So we'll put up different scatter plots and try to match it to the correlation coefficients given. Here are all the correlation coefficients we have to choose from. Here's our first scatter plot. We can see that the blue line hits every black dot exactly. So this is a perfect positive correlation. So this tells us that R is equal to 1. Here's another scatter plot. This time we can see that our slope would be positive, so our correlation coefficient must also be positive. Our only positive options are 0.65 and 0.9. So 0.9 would be our correlation coefficient for this scatter plot, since it still forms a pretty nice linear model. Here's our next one. This time we can tell that our points are heading downward, so this will be a negative correlation coefficient. The line matches most of our black points, so it'll be pretty close to -1, but not exactly -1. So our answer would be -0.95, since this is still pretty close. Next is this scatter plot. We can see that it's negative, but it's not a very strong correlation. So our answer to this one will be R is equal to -0.74, since that's the only negative model we have. We have two answers left, so we'll show the next two scatter plots. The one on the left has a perfect negative correlation because that line hits every single dot. So this will be R is equal to -1. And the other one must be 0.65. And this makes sense because the line is positive and it isn't a super strong correlation, so it's not super close to 1. Now let's recap what we've learned. While residuals can help find the best line to fit the data, a correlation coefficient can determine the strength of the relationship. The correlation coefficient, which we call R, ranges from +1 to -1. The closer R is to 1 or -1, the better the linear model fits the data.